All right, we are recording. Now, the first thing I'm going to do is go to full screen on my Zoom, and I will also go to the whiteboard. Okay, and let's see what happens. All right, now you can't see it, but I have this screen that's in my way, or a taskbar in the way. I'm going to get rid of it as much as I can. It'll come back, it always does. And there's another taskbar up here, but it's further up, and hopefully that won't be in the way too much. So let's go from here. My memory is we're in Chapter 1, Systems of Linear Equations, in Section 1.3, Applications of Systems of Linear Equations, and I believe we're on Example 7 on page 31. Is that where y'all had us being? Yay or nay? Okay. So let's pick up with Example 7, and boy, it's a bear, isn't it? Okay, I'm going to try to draw the circuit. Now, let me find out. Do all of you, or do any of you, have books? Or do any of you not have a book? All of you have books? All three. So you can see this electrical circuit, can you?
Yes, sir.
Okay, I heard James, yes. Jermanuel? Do you have a book yet?
No, I don't have a book.
Oh, you don't have a book, or you do?
I don't.
You don't, okay. So, and you have
an online PDF of the book.
You have a PDF of the book, okay.
I can send it to you if you want.
Appreciate it.
Okay. So for right now, I'll go on and write it down because it is sort of useful to do. And this is going to take a while, and hang with me. I'm going to start with a line here, okay? All right, we go from this corner over to a node, okay? Let's see if there's something else I can do for a node. I guess not. Yes, I can. Let's do that for a node. Okay, there's a node or a junction. Okay, and then we'll pick up a line again. Okay, and the line goes from here to a power supply, a battery. And that battery has a short line, which is the negative side here, and a longer line, which is the positive side there. Now those are supposed to be parallel. They're not, but get over it. You can live without it, okay? Now, oh, that's not what I wanted to do. Okay, I need to get another line. Okay, and this line will start here. No, quit that. This is where it's a pain in the... here we go. Okay. I can't get close to that one because it pulls it away. Just imagine that goes to the end there. And then I'm going to hit a resistor. And that okay. I'm going to draw the resistor freehand. Well, let's see, before I do that, let me go back to this one. Okay. I tried to connect the dots. Oh, it did two lines. All right. So let me see if I can do a resistor. Nope. This is a pain in the neck. I told you it would be, didn't I? Okay, I'm going to do freehand. Here's the resistor, and this is ugly. I understand it's ugly. Okay, there's a resistor, and we go to the next node. And that node will be one of these. Okay, or junction. Okay, then we go back to another straight line and go across to here. Okay, and then we'll do another straight line supposedly. Okay, down to another battery, and this will be a positive here and a negative here. These are supposed to be parallel, but obviously they're not. And then we'll go another line. Whoa, quit that. Another line here, and go down to another resistor. Now I'm not going to even mess with trying to draw a resistor. I'll freehand it. Okay, there's our resistor, and then we'll do another straight line. See, I told you this is going to be slow. So anytime you want to say, hey, hang it up, Jack, let's go back to what we were doing. Okay, I didn't get that done too well. And this goes across to my node or my junction here. And let's do another junction. These are supposed to be circles, but my circles aren't too good. Okay, and then we'll do another line. And we'll do a line from this circle down to the resistor, and then another one from the resistor to the other junction, and we'll freehand this. I might get a little faster in time, but there's no guarantee. Yuck, that's an ugly resistor if I've ever seen one. Okay, but you got it's a resistor, right? James is laughing at me, I think. Okay. All right. With all good reason. Okay, we'll go across here and also go across here somewhat, and we'll put another resistor in. Maybe not quite as ugly as the last one, but still plenty ugly. Put another junction in here. Got a little big on that one. And let's see. We'll do another line. We'll do a few lines here. Okay, this will go across this way to there. Another line here. Another line here. Another line here. Another line here. And let me draw in a couple of resistors here. This is a pain in the neck or some other part of the anatomy. Oh, that's a terrible resistor. Let's do another one of them down here. Y'all would have me do this on the biggest problem. Ah, that's a terrible resistor. And let's do another line. Going up from that really ugly resistor to here. I should go a little longer. And then let's do another line, and this is the long side here, the plus side here, and the negative side here. That's way too far apart, but you'll have to live with it, okay? Now, let's label some of the stuff we've got. I would try typing, and maybe I should. Let me try typing. Sometimes typing works okay, and sometimes it's really a pain. So this is going to be 10 volts here. Okay? This is going to be R1 of 2 ohms. Or I can't do a subscript, so I'll just do a R1 equal 2 ohms. Oh, I forgot. I can't write an ohm. They don't let me. So I'm going to spell it OHM. It should be an S on it, but I don't have room for that. So 2 ohm resistor there. Okay. Here's R2 right here. Okay. R2 is 4 ohms. I put a space in that one, I didn't before. This voltage supply up here is a 17 volt. Okay. This resistor right here is R4, it's 2 ohms. Okay. I'm running out of room, folks. Okay. R3 down here is 1 ohm. Okay. Now here's my problems. Oh, I don't have a problem. Huh. Not a major one. This is junction 1. This is junction 2. Here's junction 3. And here's junction 4. Now, I understand you probably can't read those well because they're not in the center. Okay? And we have resistor 3 down here. Oh, we already did that one. Okay. And across these resistors, they name currents. They're going to name this one I1. Okay. Across this resistor, they'll name that I2. Across this resistor, I'm pretty sure they'll name it I3. Okay. Up here, I don't have room above. It looks like I do probably to you, but I don't. This will be I4. Okay. This is R5 here. Is equal to 2 ohms. Okay. Whoops, that's into that one. Ooh, this is a terrible looking power supply. That's 14 volts. And this is R6 over here is 4 ohms. Okay. Oh boy. I'll put, this is I5 down here. And make this I6 here. Okay. Have I got everything in place? Not quite. Okay. I need to draw a path here. And this is going to be really fun. I need to go back to my draw screen. Not draw string, but draw string. And we're going to assume that the first loop here is going in that direction. okay? And this is what they call path 1. I like to call it loop 1, but it doesn't matter. And then path 2, they're going to put this way. Whoa, got sort of out of control. It's this way. That'll be path 2, and then path 3, they are drawing this way. And I'll tell you in just a minute why I think these are good choices of the paths that's supposed to be going in the thing. Okay? Now, I don't know exactly how best to do this. They call it path 1, 2, and 3. I'm just going to call it P1. Is that okay? P1. P2. And P3. Okay. I think I've got it all drawn here. Goodness gracious, I'm getting tired of sitting. All right. Now, for those who were here before, James and Ricky, we've done one similar to this, not quite this complicated. Okay? But for you, Jemanuel, have you done your Physics 2 yet? No, okay. You'll do this again in Physics 2, so stand by. We're dealing with two laws called Kirchhoff's laws. Two types of laws. The first is called the junction rule. This next one's called the loop law, or something like that. That's why I didn't want to call them loops rather than paths, but they call them paths, so I did too. So let's start with the junctions, okay? Now, remember here we've got current 1, I1, and it's going, and here's the reason I like their choice here. You see, this is the positive side of the battery, that's the negative side, so it would send current in this direction. So this means, and I may just draw this here. Let me draw it. Let me see if an arrow will work. Okay, that worked, didn't it? And according to this, both this path and this path are going up here, so I'm going to draw me another arrow here. Nope, wrong way, that way, yeah. Get right here. Okay? Okay? Over here, this would be going in this direction. Okay. Over here, both of these are going down, and there's a reason for that. It's the high side here, it's the high side there. So these would be going down. So let me draw this that way. And of course, through this resistor, it's going up. Okay. Now, that indicates, oh, let me go and draw one here. This one's going in this direction. Okay? Okay. So we've got our current flow through each of these resistors. Okay. And we got the current flows in and out. And just to make sure here, let's do this one. Okay. And let's just do this one. Okay. Now let's go on and do these two as well. Do I have all my arrows pointing in the right direction? I believe so. Okay. The junction rule, or the junction law. Let's start with junction 1. What do we have coming in? I1's coming in. I3's coming in. I2 is going out. So that says to me, and here comes the text again. I hope I can do a plus sign here. Yeah, I should be able to. The first one says I1 plus I3, because both has come into that. Okay, I think I'm going to back off a moment here, okay? Let's do it this way. I1's coming in, so it's positive. I2's going out, so that's negative. So let's make this minus I2. And then I3 is coming in, so that makes that a plus I3. And that's equal to 0. That is your junction rule, that the sum of all the currents coming into or leaving a node has to be 0, or into a junction. Because you can't build up charge in a junction. You can't build up current in a junction. So I1's coming in, I3's coming in, so those are plus. I2 is leaving, so that's a minus. Does that make sense? Looking at our drawing here, we see that I1 comes in here and goes up. I3 comes in here and goes up. So this one going up has to be a sum of I1 and I3. So that makes sense on just about every front. Okay? Let's go to junction 2. Okay? I1 is leaving, so that's a minus I1. Okay? I2 is coming in, so that's a plus I2. Do you follow what we're doing here? And here we have I4 is on the way out, so that's a minus I4. Okay? And that has to equal 0, right? Okay. Is everybody following this? Do you agree with it so far? That's junction 2. I2's coming in, so that's plus. I1's going out, so that's minus. And I4 is going out, so that's minus. Okay? So there's the second junction. Let's move to the third junction down here.
Wouldn't I1 be going in, though?
No, look at I1. I1 is going this direction. You see? It's leaving junction 2. Here's junction 2. Leaving junction 2, I2 is coming into junction 2, and I4 is coming out of junction 2. Do you see it? Look at an arrow. This path is going in this direction. The current flow is around like that. So it's going out of junction 2 into junction 1. This one's going out of junction 1 into junction 2. This one's going out of junction 2 into junction 4, out of junction 4 into junction 3, out of junction 3 into junction 1. You see that?
Yes, sir.
Is that making sense?
Yes, sir.
Okay. Now, if I do something stupid, let me know. Please stop me, because I have been known to do that many a time. So please, if you think something's wrong, speak it up. Let's look at junction 3 now. Okay? In junction 3, let's see, you have I3, I5, and I6. I3 is leaving, so that's going to be a minus I3. Agreed?
Yes, sir.
Okay. Plus I5, because that's coming in. Okay. And then I6 is leaving, so it's a minus I6. Okay. And that has to equal 0, because the sum of all those has to be 0. Okay. Let's do the last junction then. All right.
See,
Junction. What's that?
What's throwing me off is the books got it backwards.
Okay. All right. But they have all the signs backwards, right?
No, sir.
Okay. Well, tell me what they're doing.
For like the junction for junction 3, see, I thought the same thing, that I3 is leaving. They
right?
say that I3 is I3 plus I6 minus I5 equals 0.
Okay, that's the same thing we have here. I3 plus I6, same sign, minus I5. They just changed all the signs.
Okay.
Yeah, it's the same equation, okay? I don't know why they did it their way. This to me makes more sense. But it's the same equation. It's just they changed everything by a -1. Agreed?
Yes, sir.
Okay. So let's look at junction 4 up here. Okay, you got I4 coming in, so that's a plus I4. You got I5 going out, so that's a minus I5. And then you got I6 coming in, so that's a plus I6. And that's equal to 0. And by the way, they set it up the other way like we did last time, but it's just way more typing for me, so I'm trying to minimize the typing. I'm being really lazy here. I'm just writing it as one equation because I know this is how we're going to want the equations to look, right?
Yes, sir.
Now, that gives us our 4 junctions, okay? Now, not all those equations may be independent of one another. I can almost guarantee you they're not. But now let's do what I call the loops. They're calling the pathways. Now, Germanuel, on the pathway law, on the loop law, what you do is every time you go across a battery from negative to positive, that's an up in voltage. So that's going to be a plus 10 volts here. Okay? Going this way, that's going to be dropping in voltage 2 ohms times I1 because of Ohm's law says the voltage drop is equal to current times the resistance. The current is I1, the resistance is 2. So that's 2I1. So here's the voltage drop across this one. The voltage drop across this one is 4I2. And then you don't have any more voltage drops around that loop. So the way we can say that, voltage drop equals voltage input. There's your input. So we'll say 2I1 plus 4I2 is equal to 10. There's another equation. So let's write that down. Say again? Agreed? 2 what do we call it? 1. 2I1 plus 4I2. I don't know if I need a blank there, but I'm doing it I2. It just looks strange having all the numbers crowded in. And that has to equal 10 volts. I'm just going to call it 10. Okay, there's the first pathway or first loop. Let's go to the second loop. Okay, wow, we got 4 drops here. Here we have a drop of 2 times I4 plus 2 times I5 plus I3 plus 4I2 from here is equal to 17. Well, I want to put those in the right order, so I'm going to start with I2. That'll be 4I2 okay, plus, then let's do I3 next, I3 where was my I3? I typed it, but it didn't go in there. There it is. I3 plus 2I4 I should have a space there. I'm a real fast typer, as you can tell. Plus I'm pretty sure that's a 2I5. Oops. Equals 17. Okay, there's our second loop. I started down, I did it in weird form because I want to keep the i's in order. 4I2 plus I3 plus 2I4 plus 2I5. And that has to equal 17. That's the only voltage increase in that. Let's go to the third pathway or loop. There's only 2 resistors here, so it's 2I5. Come on, here we go. 2I5 plus 4I6 and that's equal to 14 volts. All right. There are 4 and 3, 7 equations for 6 unknowns. I guarantee you one of these is not necessary. Guarantee, because you don't need more equations than you have unknowns. We don't know which one it'll be yet, but we'll deal with it. Now, at this point, I have to erase everything to do my, well, not necessarily, to do my matrix. Okay? So, I have to erase all up here. Have I got it all right? Is it okay to erase this? What you think? Okay. So let me erase everything that I've got up here. All that work going down the tubes here, it makes me cry. Almost. It's so much more fun to destroy it than it is to do it, okay? Oh, no! Y'all are going to have to give me that equation back. It knocked out an equation I didn't want it to take out. It was my loop 1. Because this eraser has far greater reach than it ought to have. Okay. I wiped out my first equation too. So I've got my first junction and my and my first path. Okay? So you tell me that first junction again. I believe it was I1 minus I2 plus I3 is equal to 0, wasn't it? Well, am I right? I1, say again?
I1
minus, say again?
minus I2
Okay.
plus I3 equals 0.
Yeah. Okay. And give me the first loop. That was 2I1.
Yes, sir.
Plus
4I2
4I2
equals 10.
10. Okay. Those are my 7 equations. So that means up here, I'm going to do a 7 by 7 matrix, right? Now, Germanuel, this is what a matrix is. These are our variables. This is what we don't know, the I1, I2, I3, I4, I5, I6, okay? These are coefficients, 1, minus 1, 1, minus 1, 1, minus 1. These are pretty easy, all the plus or minus 1. Here we have a 2, a 4, a 2, a 1, a 2, a 2, a 2, and a 4. Those are coefficients. Our constants are 0, 0, 0, 0, 10, 17, and 4. So what we're going to do is a matrix, which is an array of numbers, and on the left-hand part of it are going to be all our coefficients in order, okay? And then right next to that is an augmented matrix with the constants. Okay, we're going to start with this one. The first coefficient is a 1, okay? So I'm going to start up here. This is going to be my matrix, and that's going to be a 1, space, space, minus 1, space, space, 1, space, space, 0, space, space. This represents I3, I4, and I5, and I6. So again, 0, space, space, 0, space, space, 0, space, space, and that's equal to 0. Okay, there's our 7 columns of the first row. Okay, now let's do the second row. Minus 1, 1, 0 for I3, minus 1 for I4, and the rest of them are zeros. So that's a minus 1, space, space, 1, space, space, 0, space, space, minus 1, space, 0, space, space, 0, space, space, 0, space, space, 0. Okay. Yes.
You have too many zeros, I think.
No, okay. The last 0 is this one here. Okay.
Right.
You see,
Wouldn't it be
okay.
I3
You got I1, I2, I3, and then, oh, you're right, don't I? How did
Yes,
I
sir.
do that? You let me do it, James. It's your fault, okay?
I was trying to.
No, you weren't. You let me do it. You get a 0 for today's participation in class. No, I'm just kidding. All right, you're right. We got 6 I's and a constant. You got it. Thank you.
Yes, sir.
All right, now the next one, let's get down to the right one. The next row is going to be a 0, 0. So 0, space, 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 0, space, space, minus 1, that's I3, space, space, 0, space, space, 1, right? Space, minus 1, space, space, maybe 1 space, 0. Okay, this is not a very pretty matrix, but nothing I do is very pretty. Is it, James? Okay, never mind. All right, now, the next one is I4 down here, this one down here. Okay, it has 0, 0, 0 for I1, 2, and 3, and then a 1, negative 1, 1 there. So it's a 0, space, 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 0, space, 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 0, space, space, 0. No, yeah. No. You let me do too many, James. Okay. I think that's a 1. That's for I4. Space, space, minus 1, space, 1, space, space, 0. Okay, not very pretty, but that's the best I can do. Those are our 4 junctions. Okay, let's do the first loop. The first loop is going to be a 2, that's your coefficient here. Okay, space, space, space. I don't know how we got 3 there, but we did. 4, space, 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 0, space, space, 0, space, 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 0, space, space, 0, space, 10. Got the right number? I think so.
Yes, sir.
So those are the coefficients for this equation. You see that? 2, 4, then 0, 0, 0, 0, 10 is your constant. Okay? For the second loop, that's this one. A 0 for the 1, for I1, space, space, space. 4 for I2, space, space, space. 1 for I3, space, space. 2 for I4, space, space, space. 2 for I5, space, space. 0 for I6, space, 17. All right. Last one, the one we've been looking for. 0 for I1, a 0 for I2, a 0 for I3, whoops, too many, a 0 for I4, a 2 for I5, a 4 for I6, and a 14. Did I do it right?
Yes, sir.
All right. Now, Jermanuel, this probably is sort of new to you, but that is a matrix. It's a rectangular array of numbers. I probably should put more spaces in it so it won't be so crowded, but I'm not about to go and do that. Okay, I think I will put one here. That probably messes up everything, but maybe one here and one here. That helps a little bit, doesn't it? Maybe one here. Okay. Okay, y'all are laughing at me. Okay, I got it. Okay, that's about the best I can do because this doesn't work out well with spacing. Okay, now, what do we want in our matrix? We want the upper left-hand corner to be a 1. Guess what? We got a 1 already. We don't have to do a thing to it. Next, what we want is everything below that in that row, in that column, to be a 0. So the next thing we want is for this -1 to become a 0. Now, there's 3 rules we can follow to do these matrix operations. The first, you could swap any 2 rows. We don't need to swap a row. We got them just like we want them. We got a 1 right up there. Maybe later we'll swap a row, but not yet. Number 2, we could change the sign of any whole row that we wanted to. And that's what the equation was doing. Remember, James said this equation was +1, -1, 0, +1. Yeah, and then a 0. That's the same equation. So you can multiply by plus or -1 anytime, or any number, anytime you want to, except 0. Don't ever multiply or divide by 0, okay? The third rule we can do is add a multiple of one row to another row. That will work here. That will make this become a 0 if we add, and I'm going to write it out here to the side, row 1 plus row 2. Okay. Ooh, that took up way too much room, didn't it? Okay, I'm going to back off here and take out my spaces. Okay, it still took up too much room, didn't it? So I'm going to see if I can move this row. No, don't do that. Select. Okay, I'm going to move this row over here. Okay, that's my rule. That's all I'm doing. That's a rule. Okay, now I can't undo that. Okay, so let's do another text. Hey, it did it. All right. I should do another arrow, but I'm not going to do that either. That's way too fancy for me. All right. So our first row stays exactly the same. A 1 space space, -1 space space, 1 space space, 0 space space space, 0 space space, 0 space space, 0. Did you have me put too many zeros in again? Okay, I don't think so. Okay, that first row stays the same. Now the second row, we're going to add the first 2 rows together. Every one. So 1 plus -1 is 0. Space, space, space. And -1 plus 1? 0. Space, space, space. And 1 plus 0? 1. 0 plus -1? -1. Okay, and the rest are zeros. Space, space, 0, space, space, 0, space, space, 0. Okay? Now, next we wanted a 0 below it. We got it. So we just write that one down. 0, space, 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 0, space, 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 -1, space, oh, it gets so crowded here, 0, space, space, 0, space, space, 0, space, space, 0. There's the, no, it's not. I messed that up, didn't I, James? You messed me up again, didn't you? Okay. That's supposed to be a 1 here, and that's supposed to be a -1 there.
You could go ahead and change the third row. Could be
What's
lazy.
that?
Could be lazy and go ahead and change the third row.
We could, but James is a really lazy character. If you haven't figured that out yet, yeah, you get that right. Okay. No, you're right, but I don't want to skip too many steps just for Emmanuel. It's his first time.
Yes, sir.
I think I would be right with you otherwise. Okay. Yeah, right. Okay. Now, the fourth row, it has a 0 right where we want it, so we write that down. So it's a 0, space, 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 0, space, 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 0, space, 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 1, space, space, -1, probably need to back up 1, -1, space, space, I've lost myself, 1, space, space, 0. All right, fourth row stayed the same. All right, fifth row, we want that to be a 0. Now we always use our leading 1. That's what we call this, that leading 1 here. So how do we get this 2 to become a 0? -2 the first row, added to the fifth row, and that becomes the new fifth row. Okay, so I'm going to come way over here and do -2 row 1 plus row 5. Okay, and it's too big. Okay. Okay, let me scoot it over some. No, don't do that. You have to do select. James, you keep forgetting what to do here. Okay, you need to have a better memory, James. Okay, so that's what we're doing to row 5. Don't confuse those things here. So -2 times row 1 plus row 5. So -2 times 1 is -2 plus 2. That gives you, let me get back here, and back here. Okay. I don't know what to do next. Okay. Okay. This is what we do next. Okay, there we go. I forget all the rules here. Okay. So -2 plus 2 gave us a 0. Space, space, space. A -2 times a 1 is a -2 is a +2. Plus 4 is a 6. So that became a 6. Space, space, space. -2 times 1 is -2 plus 0 is -2. Space. Okay. -2 times 0 plus 0 stays a 0. Space, space. -2 times 0 plus a 0 is another 0, space, 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 maybe. -2 times 0 plus another 0 is another 0, space, space. And -2 times 0 is 0 plus 10 is 10. Okay, maybe I should take out that space there. Okay, there is row 5. Row 6 and row 7 are just like we want them. You got zeros below it, so we're going to do it. So let's see if I can do this without messing something up. 0, I messed up already. 0, space, space, space. 4, space, space, space. 1, space, space. 2, space, space, 2, space, space, space 0, space 17.
Yes, sir.
All right. There's row 6, row 7, 0, space, 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 0, space, 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 0, space, space, 0, space, space, 2. James, why didn't you tell me to divide by 2? You're just sitting down on the job, aren't you?
You said you was gonna wait. You didn't.
No, yeah, right. I've heard that before. Okay. Space, space, space. 4, space, 14. Okay, now that's our new matrix. I am going to do this. It's a little fancier than I wanted to do, but this matrix became that one. Now, really what we ought to be doing is drawing brackets around them. And just because Emmanuel will think they're supposed to be this ugly, they're not. Now, this is going to make it even uglier, but you see how you represent a matrix is by drawing these boxes around. And I'm surprised it came out that clean. James said he was too, but I'm not listening to James anymore. He's messing me up. Okay. That one got a little out of control. So that's how we identify matrices. That's how they should have been looking all along. Now, I could have been drawing straight lines there, but I thought I could do it with freehand, and it's okay. All right, let's review what we got and what we want. We wanted a 1 here, we had it, and zeros below it, we got it. What we want next is the first non-zero entry in this row to be a 1, and we'd love it in the second column. We don't have it in the second column. Only places we have something are down here. Now the question is, do you want to use row 3? I mean, whatever row that is, row 5 or row 6? Okay? I'm inclined a little bit more to row 6, aren't you? We're going to have to divide by 4. Remember, that was one of our 3 rules. We could divide our whole row by that. That will give us a 1 here. Let's keep that 0, 0, which is what we want. That'll be a 1. This will be a 0.25. This will be a 0.5. That'll be a 0.5. That'll be a 0. And unfortunately, this is going to be a 4.25, which is really nasty. But that's all we can do. So let's do that. We're going to do 2 things at once now. Emmanuel, forgive me. James was pushing me along here, so I have to do it. We're going to exchange row 2 with row 6. That's moving this row up here and this row down here. And at the same time, we're going to divide this old row 6, the new row 2, by 4. Okay? So that's going to give me, let me get my fancy looking arrow back. Don't you like this? It makes it look so professional. And this time I think I will use the straight lines and draw my blocks in place. Yeah, I don't do it that way. James, why did you have me do this? Okay, that's supposed to be, where did it go? My word. Okay, there that one is. I can't get that one to come up. So anyway, that'll be it. All right, so what we do here, oh, we got to get our text back. This is a pain in the neck, isn't it? Why did you have me do this, James? Okay, we're happy with this right now. So row 1 just goes down just like it was. That's a 1 blank blank, -1 blank blank, 1 blank blank, 0 blank blank, 0 blank blank, 0, blank, blank. James puts too many zeros in here. I know. I'm trying to figure out. I go put one more blank and then a 0. Okay. And I'm going to come back here, and for some reason, okay. All right. So there's my row 1. I basically copied it down, trying to fix the spaces so they were better than James said. Okay, now, our new row 2, remember, is going to be this old row 6 divided by 4. So the first one's going to be a 0, blank, blank. Okay, this is where we run into problems. It's a 0.25. I probably didn't leave enough room, did I? No, that's a 1. Sorry about that. What are you having me put a 0.25 there, huh? Okay, it's a 1. 4 divided by 1. It's the next one is going to be a 0.25. Now, I would put 1 over 4, but that's going to be messy in itself, okay? Because this doesn't do fractions well, okay? Okay, I found... I'm going to turn off the ceiling fan. Okay. I found out I have to sneeze every now and then to keep James awake. Okay. So did it work? All right. All right. So that became a 0.25. The next one becomes a 0.5. That's this entry here. And the next one becomes a 0.5. Okay. And then the next one stays a 0. And the next one becomes, ooh, yuck. What do we say that was? 4.25?
Yes, sir.
Okay. Maybe take out 1 blank there. Okay. Now, we've got to remember to move row 2 somewhere down here. But you know, if it's all right with you, I just want to move it down 1. Is that okay? We're going to move everything. You can move these rows around wherever you want to. So I'm going to move row 2 right down here to row 3. So let's go to the end here and start at row 2. The old row 2 is going to become our new row 3. So that's going to be a 0, blank, 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 0, blank, 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 1, blank, blank, -1, blank, rest are 0, 0, blank, blank, 0, blank, 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 0. Okay. So that's the old row 2 became the new row 3. All right. Now, just because I know how I want this to look, I'm going to do this too. I want to leave this row 4 as row 4. I'll explain it to you in a minute, Javaniel, while we're doing this. James is pushing me along here. 0, blank, 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 0, blank, 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 0, blank, 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 1, blank, -1, blank, 1, bless you, blank, 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 0. Okay. Now we still got to find a place for row 3. Okay. So let's go on and put row 3 in next. Is that okay? We left that alone, so let's put row 3 in. Here's row 3, so we'll put that down here. And that's going to be, this row 3 is going to go down here now. Okay, so that's going to be a 0, blank, 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 0, blank, 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 -1, blank, blank, 0, blank, blank, 1, blank, -1, blank, blank, 0. Okay. So that's our row 5. Now we're going to move this one, what was the old row 4 down, no, old row 5 down to row 6. So that's going to be a 0, blank, 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 6, blank, 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 -2, blank, blank, 0, blank, blank, 0, blank, blank, 0, blank, blank, 10. Is that right?
Yes, sir.
All right, thank you. All right. And then we're leaving row 7 alone. Okay? Just write it down again. 0, blank, 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 0, blank, 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 0, blank, 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 0, blank, blank, 2, blank, blank, 4, blank, blank, 14. It's kind of ugly, but we can live with it. So there's our new matrix. Now, sorry, Jemanuel, we did a whole bunch of steps at once. Okay? What we wanted was a 1 here. We found out the best way to get it, or at least one way to get it, was to take this row and move it up there, and at the same time divide that whole row by 4. That's how we came up with all those ugly numbers that James wanted. Okay? Now, I knew what I wanted next was to be a 1 in this position. And since row 2, the old row 2 had it there, I just moved row 2 down here. And what I wanted next was the 1 in the 4th position. And since row 4 already was there, we just copied it down. Okay? Then I had something, I had to put row 3, so I put row 3 here. You can interchange the rows wherever you want to. And then the old row 5 became our row 6. It went here, and then row 7 stayed row 7. So I'm going to go back up to my drawing diagram and do my, yuck, it didn't draw, did it? Okay. I'm going to box in my matrix. There's supposed to be a vertical line, a horizontal line. And here's supposed to be a vertical line. James is laughing at me again. And here's another horizontal line. Okay. That's supposed to be a bracket. All right. So let's review what we've got. We got a 1 here, all zeros below it. We've got a 1 here. The first non-zero entry in the second column is a 1. We want zeros above and below. Now this above and below stuff is called Gauss-Jordan elimination. If we just wanted zeros below it, that would be Gauss elimination. Gauss-Jordan does zeros above and below. Okay? I think that's my phone making a noise. I don't care. So I'm just going to let it ring. Okay. Now, to get the first one to become a 0, all you have to do is add row 2 to row 1. That will make this a 0 here, which is exactly what we want. So I'm going to bring a text column down here and move it right about here. Okay, so what I'm going to do here, if I can do it, I don't have room to write it, so I'm going to write it freehand. Oh, this is going to be pretty, isn't it, James? Okay. Okay, he's going to laugh all over at me. What I'm going to do is row 2, that's supposed to be an R. He's laughing, I can tell. Row 2 plus row 1. All right, I hear you. You're losing points like crazy. Okay, row 2 plus row 1 is going to make this become a 0. So that's what we're going to do next. Okay, we'll start our blocks here. And row 2 plus row 1. 0 plus 1 is 1. Blank, blank. 1 minus 1 is 0. Blank, blank. Uh-oh. 1 plus 1.25 plus 0.25 is 1.25. Okay, we'll make that a blank blank. Okay, a 0.5 plus 0 would be a 0.5. Blank blank. 0.5 plus 0 is 0.5. Blank blank. 0 plus 0 is a 0. Blank blank. And then 4.25 plus 0 is 4.25. There's our first row. Takes a little more space because we got all those decimals in there. All right, what do we want next? Well, the second row is just like we want it. I wish there weren't so many decimals, but we got that 1 there, so we're going to write it down. So 0, blank, blank, blank 1. Well, I probably could stand without that blank. Okay. Blank, blank, blank. 0.25. Keep me from making mistakes here. A 0.5. Blank, blank. 0.5. Blank, blank. 0. Blank, blank. 4.25. Did I do that right?
Yes, sir.
Okay, good deal. All right, they look awfully much alike, but they are different. Okay, third row, it has a 0 where we want it, so we just write it down. 0 blank blank, 0 blank 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 1, blank 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 1. Or is that a minus 1? Yeah, you let me do it wrong, didn't you? Minus 1. Blank, blank, 0, blank, 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 0, blank, 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 0. Okay. There's the third row, just like it was. A little spaced out, but okay. Fourth row, perfectly fine the way it is. This is the thing about linear algebra. It's a lot of writing. 0, blank, blank, 0, blank, 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 0, blank, 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 1, blank, blank, minus 1, blank. Y'all are getting me lost here.
1.
1, blank, 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 0. Okay, there's the fourth row. Fifth row, again, you've got a 0 underneath that leading 1, so we're going to write it down. 0, blank, blank, 0. Is what, fifth row?
-1.
Yeah. -1, blank,
0.
blank, 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 0, blank, blank,
1.
blank, 1, blank, blank, -1, blank, blank. Is that a 0?
Yes, sir.
All right, good deal. So there's that row. All right, finally we get to another one we need to change. We need that 6 to become a 0 because we want, after this leading 1, we want zeros above and below. These were all good. This one's not. So how do we get the 6 to become a 0? Minus 6 times row 2 added to row 6. So I'm going to, again, go to my draw option here. So all right. James can laugh at me. Okay. It's minus 6, row 1. This is crowded too close together. Plus, yuck, that's really crowded too close together. What is that, row 6? Okay, that's supposed to be a 6. You figure it out. Okay. Minus 6, row 2, plus, I think I wrote a 2 there, I can't read it, plus row 6. So minus 6 times 0. Okay, let's go back here. Whoa, that's not what I want to do. select this, and we'll go right here. Ah, we got it. It's the right place. Okay, minus 6 times 0 is 0, plus 0 is 0. Blank, blank. Okay, minus 6 times 1 is minus 6, plus 6 is 0. Blank, 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 blank. Minus 6, times 2.25. That, I believe, is 1.5, right? Minus 6 by 1/4 would be 3/2, which is 1.5. So 1.5 minus 2 would be a minus 0.25. No, minus 0.5. So this is a minus 0.5. Okay, I'm going to back up 1 and take out a blank. You're out of there. Okay. And then minus 6 times 1/2 would be a minus 3 plus 0. That would be a minus 3. Minus 3. Okay? I'm lost here. Minus 6 times another 1/2 would be a minus 3, plus another 0 is another minus 3. Blank, blank. Okay? And minus 6 times 0 is 0, plus 0 is 0. We can do a 0 in there. Blank, 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 or somewhere there. And then minus 6, I'm going to pull out my calculator. Okay, I'm getting tired of this. Okay? All right. Let me, whoops, get to the calculator mode. All right, so minus 6 times 4.25. So 6 times 4.25 equal. So that's going to change sign and make that a minus 25.5, if I'm doing it right, plus 10. That gives me a minus 15.5, I think. Is that what you got?
Yes, sir.
Okay, this is awfully slow and tedious, isn't it? I think that was yes. Okay. Now, all right. Last row. It's exactly like we want. We want a 0 under that 1, so we do a 0, blank, blank, 0, blank, 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 0, blank, 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 0, blank, blank, blank. Now, at this point, James, what should we do? Yeah, divide that last row by 2, and that's the other thing that you can always do. Multiply or divide by a non-zero number, and we're going to choose to divide by 2 to make that a 1, blank, 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 2, blank, 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 14. No, 7. Why do you let me write a 14? 7. Okay. Now, that's my new matrix. And by the way, Jemanuel, we call these equivalent matrices. Okay? If you've done the row operations you're supposed to do, these all become equivalent matrices. So there's that thing. It's leaning too much, but I don't care. Okay, this one is going to try to get it as straight as possible. Okay, and then this one will come in here. Then we'll go and do one here. Okay, leaning too much here. Trying to connect here. And then, okay, pretty ugly, but still doable. Okay. So, quick review. Nothing very quick here. What do we want? Leading 1 here, 0's below. Leading 1 here, 0's above and below. What we want next, and this is why we did it, we wanted a leading 1 here. We got it. But what we need are 0's above and below. We got 2 0's below, so we're happy there, but these two we're going to have to change as well as those two. So let's start with the top. Now, is this eating way too much time? Do we need to just move on and say, you see how it works? Let's see what we wind up with. What do you think? Want to keep going? For instructional purposes? Be honest. This is slow as molasses.
It's going to take another 15, 20 minutes to finish this.
Okay? So let's take a look at what they've got in the book. Notice they set up and took a lot. They've taken a whole page. We haven't. They got to the equation there, and then you know what they say in the book? Using a graphing utility, a software program, or Joust Gordon elimination, solve that system to obtain, and they just give the answer. Okay? Now, that's really cheap, isn't it? Okay? But what we're going to do, just to give you an idea, we would, okay, get this down, we would multiply row 3 by negative 1.25, add it to row 1. That would give us a 1 here, a 0 there, and a 0 there. And then it would change these numbers out here. Row 2, we'd multiply row 3 by negative 0.25 and add it to row 2. You get a 0, a 1, a 0, and then it would change these numbers. Some of them anyway. Then we'd leave this row alone because that's the leading one we're dealing with. We leave that row alone because it's already got a 0 there. What you do here is add row 3 to row 5. And that would be real easy to do. 0, 0, 0, minus 1, 1, minus 1, 0. And that would be exactly what we want there, except we want that to be a 1, but that can be changed really easily. Then we'd multiply row 3 again by 0.5 and add it to row 6. That would give you a 0, 0, 0, and then whatever that came out, it would change these numbers. And then we'd leave this row exactly like it is. And you keep working your way over. What your goal is a leading one here, zeros below it. Leading one here, zeros above and below. Leading one here, what we just described, will give you zeros above and below. Then you'd already have a leading one here. That's exactly like we want it. And then you would eliminate the things that are up here. Now, they probably have changed, but that's okay. Okay? And you make those zeros. This is already a 0 if it hasn't changed. Make that a 0, keep that a 0 if it hasn't changed. And then by this time, you have gotten a 0 here. You also wound up with a 0 here, and you'd have a 1 here. That's exactly like you want. You make zeros above and below it. Now, it's hard to say what's going on here. At some point here, you're going to wind up with a row of zeros. You know you've got to, okay? Because you can't have more equations than you have unknowns without having a row of zeros. And you do. And what you wind up with at the end, remember, this stood for I1. This is the coefficient for I1. Remember? That's what it was at the very beginning, okay? So you have I1, and if all these are zeros here, I1 is equal to whatever that one turned out to be. I2, and all these would be zeros, would turn out to whatever that became. I3, if that became a 0, which it would in the very next step, would give you whatever that turned out to be. I4, that would be this. When you change these two, you also change that. That would give you what I4 would be. When you eliminated this and got the I5 here, eliminated that, made it 0, that would give you what I5 was. And then when these had become zeros and you just have a 1 here, whatever that would have been would be I6. These guarantee would be all zeros. Okay? So that's how they were able to write down I1 is equal to 1, believe it or not. I2 is equal to 2, believe it or not. I3 is equal to 1. And that one, I think, it's hard to see how it was now, but you've done elimination of these two, and that changed these two numbers. That gave you a 1 right here. It really did, okay? and then I4 would become a 1 here again. And it's hard to see now, there's too many steps in between. I5 would be a 3, believe it or not. I6, that's this one, would become a 2. And this row would all be zeros. Okay. Now, Jemanuel, a little time out here. If indeed, when you eliminate everything else, if you had wound up with a 0, 0, 0, 0, 0, 0, 3, you would have stopped right there and say, this is an impossible situation. Because what did this represent? All these would be zeros, and zeros equal to 3. That can't happen. If you ever get that in a reduced row echelon form like this, you can't have 0 equaling 3. Okay? But I guarantee you this would have all been zeros. And then each one of these would have been a leading 1 down the diagonal. That's what you're gunning for. And we had them up to, well, this was out of place, up to there. With that being a 1, then these would represent the various currents for I1, I2, I3, I4, I5, and I6. Once you did all that. And this one would have been all zeros. Okay, so hopefully you see how we do row reduction. Now this was incredibly slow because I was having to type it all in and make mistakes, you know, that kind of stuff. But you start with your system of equations, line them up, write them in matrix form where you just put the coefficients and the constants. Just the numerical part, leave off the variables. Then start reducing, and this is called row reduction. So you have a leading 1 here, zeros below it. A leading 1 here, zeros above and below it here. A leading 1 here, zeros above and below it there. Then a leading 1 here with zeros above and below it here. And then ultimately, by the time you got all these zeros, hopefully you can make that a leading 1, zeros above and below. Then whatever you've done to it, this would make that a leading 1, and then zeros above and below. And that then gives you your answer, because this will wind up, if everything works right, to be a row of zeros. Just forget about them. Okay, so that's what we call row reduction. Okay, the book just went straight to the answer. We at least showed 4 steps getting to the answer. And guess what, folks? That finishes 1.3. Now, 1.3, we did not do a lot with curve fitting. Okay, so if you want to do any of those, you certainly can. They're not required. Okay, any of the odds 1 through 13. Again, you don't have to do any of them, but if you do choose to do some, you can check them at calcchat.com. The answers are in the back of the book if you got them right. If not, you can go to calcchat.com. Now, I meant to say this before, but I forgot to. Notice right up there where it tells you about calcchat.com, notice there's a QR code. You can just hold your phone up to that QR code or an iPad or something else, and it'll take you right to that calcchat.com. You don't have to even enter it into your phone or computer or iPad. Okay, equation of a circle, that's again a polynomial curve fitting. That's number 15. You don't have to do it, but if you want to, you can. 17 is a population problem. You don't have to do that, but if you wanted to, you could. 19 is a net profit. If you're planning to go into business and want to use that as an example, you surely could, but you don't have to. It's not required. The network analysis we did do. So you can check the last class and see how to do the network analysis. It's a lot like we just did here with Kirchhoff's laws, only you're only doing the junctions. You're not doing any loops. Okay? So that's 21 you should be able to do, or 23. You can choose either one of them to do. 25 is Kirchhoff's laws, so you can do either 25 or 27. They're both Kirchhoff's law. Okay? Number 29 is a temperature junction problem, so you can do that if you would like. You got 4 unknowns there, and you can do that if you'd like. If y'all recall from back in Cal 2, when you did partial fraction decomposition, when you did partial fractions, remember that? That was, you can go back and review that and do 31 or 33. Also in calculus, you may have run into what I call eigenvalue problems. They're not always that. These are actually called Lagrange multipliers here. We didn't do that in my class, but if you did, you can do number 35. 37 is graph of a parabola. That's a lot like curve fitting. You can do that if you'd like. 39 is a guided proof. You can do that if you like. Its answer's in the back and at Calc Chat. And 41 is another, I guess more like a polynomial, okay? You don't have to do it. You can if you want to. Not only that, they have review exercises at the end of a chapter, okay? And here are review exercises. Again, the odd number answers are in the back of the book, but the odd number answers are also at calcchat.com. And you can use the QR code to get there. And you can do, if you choose, you don't have to do these, any of the odds 1 through 5. You can do number 7 if you, you should be able to do number 7. Any of the odds 9 through 19. You can do 21, that's pretty easy. You can do any of the odds you choose, 23 to 20, either 23 or 25, either 27 or 29. Any of the odds 31 to 39. 39 is a little more involved, okay? Any of the odds 41 to 45. Any of the odds either 47 or 49, 51 or 53. There's a writing exercise at 55 if you want to just see what they do at calcchat.com, or do it yourself or skip it. It doesn't matter. 57 is one you can choose whether you're going to skip or not. There's a true-false at 59. You can do that if you'd like. There's an applied problem in sports. I'll let you decide whether you want to do that or not. It's not required. That might be more like a polynomial reduction, so you can skip it if you want to. The partial fraction decomposition, that's something you did before in calculus, so you can probably do that. You don't need to do the polynomial curve fitting unless you just want to. That's 65. 67 is another polynomial curve fitting. 69 is probably like that, so you can choose to skip that if you want to. 71, though, is a network analysis. You should be able to do that, and that's it. All right. Any questions on Chapter 1? You don't have to do those review exercises unless you just want more practice. The odds have answers in the book, back of the book, and worked out solutions at calcchat.com. All right. Any questions on any of those? All right. If not, let's move on to, and by the way, I do have your test ready. Now, it's not the prettiest test in the world. It's one I did in WordPerfect because that's what I like to do my typing in, but y'all don't read WordPerfect. And to translate it to Word screws up WordPerfect, especially when you're trying to do matrices. So what I did, I took the one that I had from WordPerfect and took a picture of it with my wife's new iPad, and that gave me a PDF. So it's a PDF, and it's a little crooked because I didn't hold the iPad the way I was supposed to. But anyway, I think you can figure it out. I will be uploading it sometime this afternoon or evening. And here's why I say it that way. I finish this class at 1:15. But I have a doctor's appointment. It's a telemedical appointment at 2 o'clock. So if I'm going to eat anything, I've got to cram something down between 1:15 and 2. So I'm going to have a real quick lunch right after this. And then I've got the doctor's appointment. I don't think it'll take too long. As long as it doesn't go past, that's at 2, doesn't go past 3, I probably will have time between 3 and 5 to load your first test, okay? If I don't, it'll be later this evening, Like I said, it's already ready. I just got to put it on Blackboard. And by the way, your tests and anything that I send to you will be through Blackboard messages. Are y'all familiar with that? That's the little envelope icon in Blackboard. That's where you go to see, that's where you'll get your test. Now, when you finish a test or finish a homework exercise or anything else that you want to send me, you can either scan it and send it as a PDF. You can take a picture of it, like a JPEG or something like that, and send that. Either one of those, either as an attachment to an email or as a message on Blackboard. So you can do an attachment, any kind of attachment, either to an email or to a message, and send it to me either way. Okay? And that's how you'll do your test. When you finish with your test, either scan it and send it to me, or take a picture of it and send it to me. Either by email or by Blackboard message. All right, any questions on those? All right, if not, let's start chapter 2. We've got about 30 minutes, so let's get started on chapter 2. As if we haven't already been talking about matrices, chapter 2 is matrices. Chapter 1 was basically systems of linear equations that we use matrices to solve. So chapter 2, we're going to be looking at matrices as matrices, not necessarily as systems of equations. Matrices for matrices' sake. Okay? 2.1, the one we start with, is operations with matrices. Just like way back, if you can remember that far, when you were in early elementary grades, you learned how to count, right? You probably knew how to count before you went to school. But whenever you learned how to count, once you got counting down, then you started doing operations, adding, subtracting, multiplying, and dividing. Okay? Well, just like this with matrices. We've run into matrices. We've seen some applications of matrices. Now we're going to turn around and find out what operations can we legally do with matrices. That's what 2.1 is going to do. There's 5 learning objectives here. Let's start with, when do we tell when 2 matrices are equal? Okay? Now, I think I'm going to clear my slide here of all the drawings. Does anyone need this any longer? Hopefully you had plenty of time to get this cleared, to get this got copied. So I'm going to clear these drawings. Section 1.2, you use matrices to solve systems of linear equations. Okay? Here are just a little bit of rules, nomenclature, how we're going to do things. Usually we represent matrices this way. One of 3 different ways here. Okay, the first way to represent a matrix. Okay? Well, I can't get it to do. Okay. First way to represent a matrix. Uppercase letters such as capital A. Well, wait. Capital B. I can't type. Or capital C. ... Okay. Uppercase letter. That usually represents the matrix. Okay. Remember back in algebra, usually capital letters represented polynomial functions. Well, now they're representing matrices. Capital letters, A, B, or C, whatever you want to do it. Another way to represent a matrix. Remember, a matrix is an array of numbers. You have rows, you have columns. Okay? So, you can represent a characteristic entity, and unfortunately here I've got a problem. Okay? Because I can't do subscripts here. So I'm going to do a, little a, ij. Now those ij's are supposed to be subscripts. Okay? I'm going to space along here and do little b ij. I'm going to space along here and do little c ij. Now the ij's are supposed to be subscripts. Okay? Now, we don't just do that. We put these in our matrix symbol. Remember, the matrix symbol was a square bracket. Okay, do the same thing for B and C. Okay, now what the A stands for is an element in the matrix. Matrix A, capital A, that had so many rows and so many columns. Okay, pick an element anywhere in those rows or columns. Give me two numbers, two whole numbers. That's not a number. Okay, I'm just kidding. Give me two whole numbers. Two integers, positive integers.
1 and 2.
1 and 2. Okay, really creative, okay? So A sub 1, 2 would be you go to the first row of matrix A and go over to the second column. So the first row, second column, that would be A sub 1, 2. Give me two other integers, positive integers.
3 and 4.
All right, very creative here. So go to matrix B. Its entries we're going to call little b, every entry, but every entry has a double subscript. The double subscript first stands for row, then column. So you go to matrix B, go down to the third row and the fourth column. There is your B sub 3, 4. Okay? So you could represent this as a matrix by putting another square bracket on it. And ooh, that's supposed to be a square. Oops. Well, that helped a little, didn't it? No, it didn't. It's going all over the place. I can't do anything with that. Okay, finish the bracket and you see what it is. That's Bij. Or Cij could represent any element in matrix C. Pick any other two integers. Give me two more integers.
5 and 6.
Oh boy, I knew that was coming. Okay, that means in matrix C, if you have at least 5 rows, go down to the 5th row, and if you have at least 5 columns, go over to this, 6 columns, go over to the 6th column. That's your matrix entry C 5, 6. So you represent Cij with all the entries, I going from 1 to n, where n is the number of rows, and j going from 1 to m, or vice versa. I from 1 to m, where m's the number of rows. J goes from 1 to n, where n's the number of columns. And then any entry in there is represented by Cij. C7, 14. C3, 2. Whatever, okay? Those are another way. And then the final way to represent this is the good old way we're used to doing it, and that's just drawing your brackets here, as big a bracket as it takes for you to do it. And I probably didn't draw it big enough. Okay, put your brackets and then put every element in there. A11, A12, A13, A14, A15, all the way up to A1N, because you have N columns. A21, A22, A23, A24, all the way up to A2N. And then A31, A32, A33, A34, all the way up to A3N. And keep going down here all the way till you get the last row is the mth row, AM1, AM2, AM3, AM4, all the way across to AMN. Those are subscripts. That's how you list them. That's how we just did the others. It takes me way too long to type them or write them. Look at your book. Sorry you don't have one yet, your manual, but did you get an idea of what I was talking about?
Yes.
Okay, good deal. So, here comes a definition of equality of matrices, however you name your two matrices. And I'm going to write this as a text. Is that what I'm in now? Okay. I'm going to try to do this reasonably here. Two matrices. Yeah, I already did it right. Okay. Capital A, that's one way to refer to them, equal to, and then the other way will be the Aij and capital B equal to, okay, I need a bigger box. Okay. Little b ij are equal when they have the same size. We'll call that M by N. Okay. M standing for number of rows, N number of columns. So they have to be the same size. And A sub ij, I should have left an extra blank there. Okay, is always equal to Bij. For every, and I mean for one, oh boy, I don't have the symbols. I'll do the best I can. It's a less than or equal to, so I'll come back in and draw the equal sign in a minute. I is less than or equal to M, and 1 is less than or equal to J, and that's less than or equal to N, where N is the number of rows. Now that's what it means. That's a lot of blah, blah, blah. And James, if you have, Germanuel, if you haven't run into this before, when we talk about a matrix being an M by M matrix, that always means M rows, N columns. The I's stand for the row number, the J's stand for the column number. So therefore, I's are always between 1 and M, and can be 1 and can be M. That's why I need equal signs on them. And J's are always between 1 and N, where that could be. So what this means, that if you have the same Ij entry in A to the Ij entry in B, if those are every one of them identically the same, then the two matrices are equal. Okay? Let's say the first matrix was 1, 2, 2, 3. Okay? 1, 2 in the first row, 2, 3 in the second row. If the second matrix is 1, 2, 3, 2, even though they have the same entries, they're in a different order, they are not equal. They have to be same entries in the same order, exactly the same locations. Okay? Now, the reason I stopped where I did is I wanted to put the symbols here, and they really come out ugly. Ups, what are you doing? And this symbol here. These are supposed to be square brackets, by the way. If they don't look like it, it's James's fault, okay? Okay, and these should be less than or equal to every one of them. Okay, that's the best I can do. Probably not the best, but okay, those are less than or equal to signs. That's what we mean by two matrices being equal. If you had this matrix here and this matrix here, number one, they've got to be the same size. Same number of rows, same number of columns, exactly the same. And not only that, every entry in each of those matrices, the corresponding entries, have to be identically the same. If that's the case, the two matrices are equal. All right. Now, I'm going to clear the screen here. How are we doing on time? Yeah, we got 15, 16, 17 minutes, okay? Now, here's example 1. And here is example. Here is, consider 4 matrices. Here's the first matrix, cleverly named A. Okay? A is, now this isn't going to look nice, but I'm going to do it. 1, 2. This will really not look nice. 3, 4. That sounds like James came up with that one, didn't it? Okay. All right. There's matrix A. Here is matrix B. Okay, what I'm going to do here is reduce this one big time. Okay, and then do another text here. Here's matrix B. Remember, matrices are named capital letters. Okay, well, this is a little bizarre because it's a 1, 3. Say again?
1 by 1.
Okay. That's a 2 by 1.
Yeah.
2 rows, 1 column. Yeah.
Yeah. The second one, the C is a 1 by 1.
Yeah. The first one we did was a 2 by 2. 2 rows, 2 columns. This is a 2 rows, 1 column. I don't have it drawn in there yet, but I'll try to get to it in a minute. Now this next one, C, is equal to 1, 3. Okay. I don't have my bars put in place yet. I'll get on those in a little bit. And here's matrix D. Capital letters, of course. And 1, 2. Okay. Now for the drawing part, the part we all love and anticipate. That's the symbol that makes it a matrix. These are supposed to be perpendicular. They're not. Okay, pretty ugly, huh? Don't answer that question. Boy, they come out ugly. I'm also getting awfully hungry. Sorry about that. If you hear a growling going on, that's probably my stomach. Okay. Okay, after all that, there are 4 matrices. And as James was doing, which was a really good idea, name the size of this one, someone other than James. A. It's the size of A. Okay, James, help him out.
2 by 2.
B.
1 by 2.
Row by column. 2 by 1. C.
Number 1 by 2.
1 by 2. D.
2 by 2.
2 by 2. Now, there's any chance that A and B could be equal?
No.
No, they're not even the same size. Okay? How about B and C? Could they be equal?
No.
No, they're still not the same size. Even though they have the same elements in them, they're not the same size. B's are 2 by 1 and C's are 1 by 2. Not the same size. They cannot possibly equal. Is there any way that A and D could be equal?
Yes.
How?
3. X could equal
If
3.
X is equal to 3, those are equal matrices. You're absolutely right. Because X is usually a variable. If you choose it to be 3, yes, indeed, those would be equal matrices. Okay. Any questions about that? Now, let's talk about some names. A, because it has the same number of rows and columns, is called a square matrix. Now, B, because it only has 1 column, no matter how many rows it has, if it only has 1 column, it's often called a column vector. A column matrix, and that's the same as a column vector. Later we'll see a vector is an array of numbers with just 1 dimension. So it could be either a column matrix or a column vector. C, can you guess what name it could have?
Row matrix.
A row matrix or a row vector, exactly. And again, D is again a square matrix. Same number of rows and columns. Now, there's something else we can do, and we will do a little bit of this, but not too much. We could take that first matrix here and draw another. I wish I could draw, let's see if I can. Okay, I'm going to draw a vertical line here. Try to make it vertical anyway. What I've just done here is what they call partition that matrix. That square 2 by 2 matrix I partition into 2 column matrices. 1, 3 is the first column matrix, 2, 4 is the next column matrix. You could have done the horizontal line and made them 2 row matrices. 1, 2, a row matrix, and 3, 4, another row matrix. This is called partitioning a vector, okay? And we will do a little bit of that, but really not very much. So I have no idea why they introduced it here. We're not going to use it for a while, okay? Now, since we're there, and since we said that a column matrix may also be known as a column vector, and a row matrix could also be known as a row vector, let's say this, and let's use these two. There's a column vector 1, 3, same as B, and another column vector 2, 4 that they don't show here. Okay? Now, because they can call them a vector, vectors are usually written as, this is really going to be hard to do, but I'm going to try to do it. A vector is usually written in boldface if it's in your text. and let's call it little a. Now, I can't type boldface. This doesn't let me type boldface. Now, what I might be able to do, now that I think about it, is increase the line width. So let's see if I can do that. No, that didn't do anything. Let me do another one down here and see if that would. No, it looks the same. So since I can't do bold in this, what I'll do is draw an arrow over it. Okay? Now, when I'm doing it, I draw an arrow. Now, that is way too long of an error, or too big of an error, but that would be. So this could be a sub 1. Okay? I'm sorry, I didn't put my 1 down there. But vectors are usually either bolded, lowercase, bolded, with, if they're not bolded, you put an arrow over it. Now that's way too big an arrow. Here's how I would typically do the arrow. I would do it like this. I don't draw these well. Okay, something like that. Draw an arrow over it. That would indicate a vector. Now, I meant to also make this a subscripted. So this could be vector A1, 1, 3, and this could be vector A2, 2, 4, and then you could write these as vectors. This time I'll just do it like this. I think I have to go back to text. Okay, and do A, and this is supposed to be a sub 1 that I forgot to do. It's supposed to have an arrow over it. I can't do that. Then do our vertical line. I'm going to skip a couple spaces and then do an A2. That's supposed to be a subscript. And imagine that I put an arrow over it. And then we're going to do the line. And let's see if it's still blue. Yeah, it is. And that can represent a matrix, okay? Except, since we're trying to represent it as a matrix, I will also put it in a matrix block. So there's yet another way to represent a matrix. Make it as a partition with either row or column vectors. If you had done this as row vectors 1, 2, and 3, 4, then you put A1 on top, A2 on the bottom, and then close it with the square brackets. And that's how you would represent that you would have a partition there and draw a horizontal line in between. Okay. Why they go into that here, I'm not sure, but it is, everything they're saying is true. We're not going to use them for a long, long time. All right, we've got 5 minutes. Let's see if we can define matrix addition. Okay? All right. If capital A, which stands for a matrix, is equal to, now I'm probably not going to have time to draw the bars because it takes too long, A, and these are supposed to be subscripts, IJ, and matrix B, capital letter B, is equal to, it's supposed to have a box around it, I don't have time, B, and these are supposed to be subscripts, IJ, okay, sorry, and both of these are matrices, of size M by N, M rows, N columns, then their sum, in other words, we're adding two matrices together, is the it's also got to be an M by N matrix, an M by N matrix. We'll name it A, cleverly named, plus B. Okay, I usually wanted the space there. Okay, and that matrix A plus B will be equal to the Aij entry of J. Those are supposed to be subscripted, plus Bij. Ah. Okay. Okay. The sum of two matrices, whoops, capital E, of different sizes is undefined. In other words, you can't do it. Okay? Let me elongate this out to make it a little bit easier to read, maybe. Okay. Now, imagine, folks, I put the boxes here. A box here and here that indicates that's a matrix. A box here and here that indicate that's a matrix. And then you just need one box here, there, and there. A single matrix, because this is a single matrix. Okay? So, the only way you can add two matrices is they are identically the same size. M by N. M rows, N columns. If they are not, you cannot add them. A 3 by 2 cannot be added to a 2 by 3. You can't do it. They're the different sizes. Okay? Now, how do you get a single entry in that sum matrix? Add the corresponding entries in the first matrix. A11 plus B11 gives you the sum matrix 1, 1. A73 added to B73, that's going to give you the 7th row, 3rd column entry in the sum matrix. Okay? You cannot add two matrices if they're different sizes, and when you're adding two matrices, every entry is a sum of the corresponding entries of the original two matrices. All right, I think we're out of time. We are. We'll begin next time with example 2. Okay, we didn't get far. Well, we might have gotten far enough along for a homework exercise or 2. Let's see. Yeah, you can do either 1 or 3 on page 48. And we'll hold off and do the rest of those next time. Okay? So we'll begin with example 2 there. All right. Now, what are your deliverables for today? Well, don't worry about turning in any homework exercises. Just work on your test. The test I'll be putting out there sometime between 3 and 5 if I can. If not, they will be it'll be sometime after 6:30 because my 5 o'clock class goes till 6:30, so it'll be sometime after that. All right, any questions?
No, sir.
All right, good deal. Great to have 100% attendance. Keep it up. We'll see you on Thursday. All 3 of you, right?
Yes, sir.
Good deal.
Yep.
Yes. Did you?
I just wanted to make sure that he got the download for the book. I sent it to chat.
Oh, Germanuel? Is that who you're talking to?
Yes.
Yes. Did you get it?
Did I get the book?
All right. Super. Excellent. All right.
Okay.
Thank you, Ricky.
Welcome.
All right. I'm going to stop the share now. And I'll also end the recording. So bye-bye, everybody. Be safe. And hopefully I'll get you the test sometime later today. Okay? All right. Take care. Bye-bye.